practice of protecting our assets. From there we have started, right? And if your assets are related to computer, if your assets are related to computer, either your computer components or computer devices are, the routers, switches and all other stuff related to computer, then we will be calling it as a cyber security. That type of security, you will be calling it as a cyber security. In the security, we have seen how to apply the security. For that, we started to understand the goal of security. We have seen the goal: confidentiality, integrity and availability. This was the goal. So when we started developing security, you need to ensure that you need to ensure implementing your security measure, you need to ensure confidentiality, integrity
Your voice
and
is
availability.
not clear.
Voice is breaking, right?
Yes. Now it's clear.
Okay. So it was completely the CIA trad, and in that we have to ensure the confidentiality, integrity, and availability. Right? This was the security life cycle, and after that we started to understand what a strategy we are following to protect it, or what all are the phase are there into the security life cycle. When I said phase, you said there are 4 phases in the security life cycle. First phase was prevention, second phase was detection, third phase was control, or you can say response, and fourth phase will be analysis. These all are the 4 phases that we are going to. So in the first phase, we started to understand the prevention. In prevention, we have seen, prevention is the technique, you can say, which we are using to protect our resource before the threat come. We will protect before the threat come. So that will come to the prevention. In the prevention, we are following a strategy to protect our assets. So let's suppose if you say we are following one strategy to protect our assets, is it again breaking, guys? See, just now I have restart my the firmware started to it has been flashed out. From that time itself it is running very much slow, and I don't know, internet is also slow. If daily these problem will come, literally without any suck of internet. Okay, now guys, can you please check it? Am I audible?
Yes, sir. Now it's clear, sir.
Yes, sir.
Okay. The laptop is also running so bad. I don't know why these things are happening.
Turn off webcam, sir, if it is network connection.
Yeah, we can turn up the webcam, but I am using, the faster internet here. When the cycle used to be broken out, I used to be like, now are you able to hear?
Yes, sir. Now it's clear, sir.
Yes, sir.
Okay. So in prevention, guys, which was the first phase, in prevention we have seen this is the first phase of your security life cycle, and the purpose of prevention is to protect your resource before the threat comes. Before the threat comes, we will protect our resource. That was the prevention. But what is the strategy we are following here? What is strategy we are following to protect? So the strategy is layered security model. Layered security model. In the layered security model, we have seen the top layer will be the perimeter layer. The topmost layer will be perimeter layer. We have seen specifically in AWS data centers how they are getting protected. So those protection of the data center by using the fencing cable, by using CCTV camera, by using security guard, basically that will come under the perimeter. And after perimeter, we will be having the network layer. In network layer and then system layer. Once after system layer, you will be having application layer and then you will be having data layer. So you will be protecting as per the layer. You will basically harden it. Why the word we are using hardening here? The reason why, because we are implementing the security, measure before the threat come. That's why we used to call it hardening, because we are making our layer so strong. Either it can be our network layer, our system layer, our application layer, or it can be data. So what exactly our objective here is to strong your network, strong your system, strong your application with respect to the security. So we have started with the second layer, which was hardening, which was network hardening basically, which was network hardening. So we have started from here under the network hardening. In the network hardening, if I show you, this is the four phase, right? The first one is prevention, second one is detection, third one is response, fourth one is analysis. This was the security life cycle phases: phase 1, phase 2, phase 3, phase 4. And in prevention, we are following the layered strategy to protect it. So layer will start from perimeter and then network and then system and then data and then PKI and identity management. These all we will be learning one by one. So right now we are learning the network hardening. So network hardening is nothing but it is an activity. By using this activity, we will try to protect the network. Our objective is to protect the network by doing the network hardening. And technically, if I tell you what is the goal, so you are going to stop unauthorized access, misuse, and modification. So this can be achieved. The network hardening can be achieved through two things. One is network discovery hardening, and second one is network architecture security hardening. Means if you need to make your network strong, guys, if you need to make your network strong, so either you will go with the discovery hardening. Discovery hardening means some of discovery protocol you will try to block or you will try to disable. In network architecture security hardening means the method which you are using, to architect your network, that approach of it will be with respect to the security. So you will be changing your approaches also of your network architecture. Maybe you will be using some additional firewall or some dematerialized zone to harden your network. So these all are the two solutions that has been given, and now this is the network security vulnerabilities. So as we have seen in the prevention, when we were learning the prevention has given us three tasks: task number 1, task number 2, task number 3. So the first task was assessing your assets. Assessing the assets means what part of the assets we are going to protect. And second, after assessing, you will find out the vulnerability. So basically these three will be applied here, and after that you will apply the countermeasures. You will apply the measure, you can say directly. So these all are the tasks that has been given under the prevention. So first of all, you have access here by using one inventory. By using one inventory we have used under the AWS, under the system manager. We have used the inventory, and easily we can find out the details of, how many number of machines you do have, so many number of machines if you do have, even n number of machines if you do have. So what you will get, you will get the details, entire details of those n number of machines. Later on you can decide what to protect, what to not protect. In the second, we are now going to start with the vulnerability. So if you need to find out the vulnerabilities, guys, the weaknesses in your network with respect to the security, if you will find out the vulnerabilities and if you fix it out, your network will be strong. So first of all, you are going to find out the vulnerability. So if you need to find out the vulnerability, then you do have a question from whom you are going to, you do have a fear, from whom you are having the fear, who is creating the fear basically. So fear is of exposing, fear is of altering, fear is of disability, fear is of gaining the unauthorized access. These comes as a threat or fear, you can say. And how will you come out of it, and how the people is going to disclose it? So when I say people, means hacker or attacker, hacker or attacker. Basically they do have types also. Hacker used to be of three type. One used to be have white hacker, we used to call white hacker, and black hacker,
Ethical.
and gray hacker.
Okay.
These three:
Great.
white hacker, black hacker,
Ethical.
gray hacker. When you are saying ethical hacker, so it comes under the white
White
hacking,
ethical.
white hacker. So basically, they will try to find out the vulnerabilities in the IT resources which generally people and company organizations are using. But the black hackers, they will just, hack for any other purpose, not for, finding out the vulnerabilities, or not for the purpose of, ethics won't be there basically. If it is ethical, white one is ethical, so it is non-ethical, you can say. And some of gray hacker are also there. Gray hackers are also there. You cannot judge them on the basis of ethics. On the basis of ethics, you cannot judge them. So they are gray hacker. Sometimes they can be white or sometimes they can be black. We cannot come to know. So these type of the people, attacker, hacker, what they can do, these three things. They can do the network mapping, they can do the port scanning, they can do the traffic sniffing also. And these three technology, or these three discovery threats that they can use to get the details of your network. So when you take the first one, which is network mapping. So in network mapping, what it will do, it will expose the topology. Means topology means how the connections are made. For example, there is a router and there is another router. This is router 1, this is router 2. This has been connected to multiple switches here, switch 1, switch 2, and later on this switch has been connected with multiple PC, multiple PC. So exposing the topology means they will come to know there is two router, two switches, and they are connected with three different computers. Like that, they will come to know. And attackers basically use this technology to they will try to know basically how many devices, or which devices and hosts are present in this network. And for that, they can use ping command, they can use traceroute, they can use nmap. So these all are the way that will expose our system. So this is what we have seen yesterday also. These all are the vulnerability, guys. Next one is port scanning. So if anybody will use nmap, so if anybody will use nmap to scan the port, this is the port scanning tool. So by using this tool, generally you will scan the ports, which ports is open, which port has been closed on which particular host. So even you will come to know, with this will expose your protocols in port. Along with that, we are having packet sniffing also. Packet sniffing or traffic sniffing, we used to say. So in the traffic sniffing, as I have told you, Here, the data can be read in the middle while transferring the packet. So how you are going to protect yourself from traffic sniffing? So I have told you how to, like, you have to turn off the Promiscuous mode on the NIC. That was one solution that we have seen yesterday. And it was, your the tool which perform this type of work is Wireshark. It will read your pro it will read your data if you transfer, right? Along with that, in the network hardening, you can, you can, if you now you are going to, you find out the vulnerability, you got the vulnerability, and now if you need to resolve it, what you can do is, if you want that, if you want to protect against network mapping or port scanning, so these two protocol, ICMP and SNMP, you can block first of all. And then second, if you need to work against the traffic sniffing, then you have to disable Promiscuous mode on NIC. What this Promiscuous mode does here, it will open the packet at the NIC and it will try to read what exactly this message is. So rather than opening there directly, we can deliver. We cannot use hubs, we should use the switches, and we should always encrypt our data whenever we are transferring. These we have seen it yesterday all. In the same, we came to know about a service of AWS, which is AWS Inspector. This inspector service will find out the vulnerability. It will find out the vulnerability in our network, where the port is open, which port has been open, who can reach through multiple sources to that what do we call port, like that. This will find out the vulnerabilities. Inspector will find out the vulnerabilities, and once after finding out, it will give you one findings. It will give you findings. In the findings, we can check it out. So we have done this lab yesterday, and we have used the Mason inspector to assess the network exposure of an EC2 instance. We found a port which was which was reachable from the internet yesterday, which was port number 23. And later on, we have modified the security group to make it secured. Another discovery countermeasures, you can record the traffic that is entering into the network by using a firewall. You can watch any unwanted IP address which is coming up into your network. You can monitor ports. You can limit protocols. You can limit location where the remote administration can be done, and you can implement authorization, who is authorized, authentication. Who authentication means something you have to prove that you are authorized. So here you will be having authorization, authentication, and accounting. Basically, these three triple A policy will help you to get the clarity, like who is going to access what kind of resource. So that was the discovery one. Before it, we were having the discovery hardening. From here, now we are going to see the network architecture hardening. Because if you go back and if you see how we are going to protect, so it has given us two method. The method number one is network discovery hardening. It is all about the protocols and port. This is all about protocols and port, which port and which protocol is enabled on which particular network node, that you can come to know by using some network utility and solution. Now I'm going to show you how to protect by using the architecture, right? So this part also we have done it, guys. This part means the inspector part. We have already completed the inspector part, right? Now I'll show you network architecture hardening. So in the network architecture hardening, now you will harden your network by using some architecture. Architecture is all about, the same as I have told you yesterday. From here I was about to start. So let's suppose the architecture says this is your inside, this is your outside internet, and in between of it we can keep a firewall. So where to keep a firewall, where to place the firewall? Placing up the firewall is also a part of your architecture only. So in the middle of it we have placed the firewall. Now if any traffic will go from inside to outside, outside is internet, inside is your company or organization. So basically what a company need, if you will be learning further, you will be having a question in your mind, what a company need, what an ORG organization need. So organization need three things. The point number one is any organization, they want that if they are inside, in means this in, out means this out. So inside to outside communication should be possible. Inside to outside means if any traffic is going from here to this firewall, from this firewall to this outside network, so this should be available. The second one, outside to inside, it should be blocked. So if any traffic is coming from outside, so it should be blocked here at the firewall. It should block. This is the responsibility of firewall to block it. So this should not work. And the third thing is if anyone is from outside and he is authorized, so he should able to access the inside network from outside. This is the company requirement. Now companies are using different strategy to protect their network architecture. The first one I have told you in the networking, like we can divide our network into two part, right? As if you can remember, one part we can keep as a public subnet, second we can keep as a private. This again come under the same architecture, like you are going to harden with respect to your network architecture. Or else at the place of firewall you can use something called IPS and IDS also. These all are again some tools that we are using to prevent our network, IPS and IDS, including firewall. So if you purchase any firewall appliance now, these both will be coming with the firewall, IDS and IPS. So you will be able to harden your network architecture by using either network firewall or you will be using the IPS, which we used to call intrusion prevention system. It will protect your network from intrusion. If somebody will be entering in your network without any permission, so what it will do? It will try to protect your network from intrusion. And the other example, if I can tell you, it is creating private subnets and accessing your ACL. So these all are the method that has been given here, so that we will be able to protect by using the network architecture hardening. So if you want to do few labs of it, the lab will be coming of network firewall later on. But this ACL and subnet we can do it now when we need to protect it. Shall we do it, guys? One more lab of network hardening.
Yes, sir.
But there is a problem of permission, there is a problem of permission. So I need to check it out whether in which lab we do have the permission of this kind of activity. So we are going to use network ACL, subnet and all. So if you go back into the networking lab, you will be able to do. So guys, if I'll show you this one, this lab, let's say we are here. If we go to networking, both we will try to do it now. So under the networking, if you can use 261 or 262 lab, any one of the lab you can use. Let's say 261 we will try. I think the labs are there in security. Let's check it out. Network hardening, system hardening, data security, identity management. It is there in the detection. One lab is there in the detection. Either that we can use or else we can use this one only. Yeah, let's use this one. Let's start the same lab number. I just let me show you. In the networking, if you go, lab number 265 or 263 or 261, any one of the lab from networking we can use. So what is the objective here, guys? Let's say I'll open the same document to tell you the objective. So here it is telling four things. For example, the first thing is your firewall, right? And second thing is your IPS. IPS basically it is intrusion prevention. So what it will do? It will detect the intrusion, and after that it will give you an alert to you. It will give you an alert like one it has been detected one intrusion. So for that it will give you one alert. Now it can also go under the detection as well, because even though it is detecting. Plus, whenever you are learning the network hardening, it means that if you will be changing something in your network architecture by using this IPS or firewall, that also we can do. Correct? Are you getting my point or not? Why this IPS and firewall is coming into the detection? Just because once it will detect, it will detect first of all like one threat or one threat or risk came here. Now it will give us the alert. So this detection technique, this comes under detection, but it will come into detection. But what we are doing now, we are making our network strong. For making our network strong, we have to use this also into the network hardening. That's why it went into detection, but here also we can use. Not only these two by adding up the security component, but you can do it by doing the segmentation of your network. By doing the segmentation of your network. Creating private subnets. Using network access control list. So my purpose here is to start this lab is to tell you about these two things. The point number one is network security group, and point number two is network ACL. This is going to be important here. So how they both are working, and when it comes to the architecture, you must have to use firewall, IPS or IDS tools, and how you are placing this concept you need to understand. This concept you need to understand. So let's talk about one single architecture here. let's talk about one single architecture with respect to the need whatever we do have. So what architecture we are going to learn now? So first of all, I'll show you architecture later on we will be using. So let's say this is your network, and in this network, this is the network, or you can call it as a VPC. In this VPC, you have created two subnet, subnet 1, subnet 2. You can call it as a public, you can call it as a private subnet. Generally in public subnet, we are keeping EC2 instances, and in the private subnet, we are keeping up the databases. Let's suppose some traffic from outside it is coming. So your network ACL here, it will work as a firewall. For now, this will work as a firewall. So this network ACL will decide which traffic should go in and which traffic should go out. Who will decide? This network ACL. Now either this network ACL you can associate with the VPC, or else this network ACL you can associate with your subnet. It's up to you. It's up to you. Now I'll show you the case of 3 ACL together so that you will be having the clarity. Clarity how? Let's see here. This is one machine. This is one machine. EC2 instance, right? This is one machine EC2 instance. This is another machine. For now, let's consider this is your web server. This machine we used to call it as a web server. This machine is your database server. Database server. And the third we can use here as a, let's say, a web server, database server, and let's say file server. File server. These three different servers I am using. It means if you talk about raw server, you can use EC2 for each. You can use EC2 for each. So let's suppose for now, this machine you are keeping in one subnet. This is your one subnet. This machine you are keeping into different subnet, which is subnet 2. This machine is into different subnet, which is subnet 3. So we can say this is subnet 1, this is subnet 2, this is subnet 3. Now each subnet will be having their own network ACL. Each subnet will be having their own network ACL. And these three network ACL we will be keeping here basically. So this is working as a firewall now. So if any traffic from outside it will come, let's say this is internet. From here, if any traffic we are sending, let's say we want to send, if we want to send the traffic from here to this server, and the traffic is, it is a web server, it means that you will be sending HTTP traffic. Now this HTTP traffic only you will allow here into the network ACL. HTTP traffic you will allow in the network ACL. In remaining traffic, let's say this one is having database, so it will be asking for MySQL, right? So this traffic, if it will come from here, this will go to this one, this one. And if file related traffic is coming, this firewall will send to this one. This will allow, remaining will get blocked. Let's say if you are sending HTTP to this database in file server, this firewall will block here itself. See, I'll tell you the clear picture. Some of you might be thinking, these things we can do it by using network security group also. You can do it by using network security group. So if you are using network security group, so there are some limitation with the network security group. this network security group you can use with only EC2 instance. That is the first thing. And in the inbound, in the inbound, in the inbound, whatever rule you are allowing, whatever rule you are allowing in the inbound, rule allowing, whatever the rule you are allowing here, means you are making some rule allow. Let's say HTTP you are allowing here. It means that the same rule should be allowed. It should be also allowed into outbound. Outbound. But what will happen? Here you cannot, here you, if you want that, like inbound should be there, outbound should not be there. Outbound should be disabled. In that case, what will you do? You cannot, there is no option of deny here. But here in the ACL, you will be able to deny. Means if it is your ACL, network ACL, so if inbound is coming, anything is coming in the inbound, anything, any protocol you are allow, you can allow it, or you can deny in the inbound. In outbound also you can allow and you can deny in the outbound. Are you getting my point, guys? What I'm trying to explain here?
Yes, sir.
Yes, sir.
Let's see this example once. Let's log in into the lab first. Yes, Mayuri, we have done with the attendance. I'll mark your attendance. No need to worry. So here we go. Let's say we are entering into VPC first. To understand that, we have to go into VPC. So as I have asked you one question yesterday, whenever we are creating a VPC, then let's say if we are creating only a VPC, we are giving the name of VPC, let's say sec VPC, security VPC, and CIDR range, let's say we can use 192.168.1.0/24. This is my network CIDR and everything will be as it is. Now what we can do is we can add the value, add somewhat more tag. Let's say this tag we will try, let's say name and DEP, department, we can keep it as a networking, net. So I'll be keeping one more. I'll show you why later on. I'll show you why. So once I am creating the VPC, three things are getting generated with the VPC itself. One will be the network ACL, and second will be your DHCP option set, and third will be your route table. Right? These three will be created together. Now let's create it once. So VPC has been created. This is the CIDR value. If you click here, this is the IPv4 CIDR. Now these three things has been created: the ACL, the DHCP option set, and route table. Now if you will use this ACL, let's say if I'll be using MN ACL. This is the main network ACL. MN ACL we used to call. MN ACL. This MN ACL, our main network ACL, you will be using with the entire VPC. It is made for using entire VPC. So let's say, are you able to satisfied with it? Means in the main network ACL, if I allow HTTP, if I allow MySQL, if I allow, let's say, file transfer protocol. So if I'll allow all these three protocol into the network ACL, so our resources are into three different subnet. So what it will do, it will allow in all the subnet, all these three protocol, it will allow in all the subnet. If you will use this main network ACL, then it will allow in all the subnet. Either if you block here, it will block all. Are you getting my point or not, guys?
Yes, sir.
That's why we are using three different network ACL. For each subnet, we are using different network ACL so that you can take some independent decision over here. So let's say if I open this main network ACL, this main network ACL will be for your entire VPC. So if I open this, it is giving us inbound rule and outbound rule. Inbound rule and outbound rule. So what? We did not modify this ACL. We did not modify this ACL. So by default, if we create the ACL, how does it create? Let's say edit inbound rule. So you can check it out. 100 number all traffic is allowed here. All traffic is allowed. And if you go back to outbound also, all traffic is allowed. All traffic. If you can edit, you can check it out. This is the comment, the last one which is coming as here. It is coming. It will just tell you how to write. But the first one, this 100 one is the actual traffic. So by default, inbound and outbound both are allowed. How it is allowed? Because it has been created while creating the VPC. But straight away, if you create a new ACL, then how it will look like? See, create new ACL, you just give the name, my new ACL. And if I'll create in any VPC, let's say sec VPC, I'm creating another ACL, I'll create it. Now let's see this ACL, my new ACL, which is this one. What is my new ACL? Check it out whether inbound, outbound rules are available here or not. See, inbound rules, no. And if you go back to outbound rules, no. No inbound, no outbound. See, no inbound, no outbound. Right? So it is completely secured, correct? This is completely secure. Or even the main network ACL which we have used before, main network ACL, you can modify that also. But once after modification, you need to just allow the protocol. So for example, this ACL, in this ACL, I want to add a rule, edit inbound rule. I want to add a simple rule. Let's say I'll give here priority, let's say 1. And the protocol which we are going to use here is, let's say, RDP. Means in this particular network where I am going to attach this firewall rule, that is only allowed. That is inbound is only allowed. Save the changes. It means that only one traffic is allowed. Now in the ACL it is allowed. Now this ACL you can attach it to any subnet. You can attach it to any subnet. In that subnet you can create the machine and you can check it out. So for example, let's say if I go to the subnet and if I create a subnet also in the same VPC, I'll just give the subnet as a my let's say sec subnet, sec subnet 1. In preference not, we can keep the IP address range here as we all know 2 subnet we can create, for example. Now so this subnet I am creating. Now in the same subnet, for entire this subnet, any IP address if belongs to this subnet, if any IP address which belongs to this subnet, you are going to keep any machine. Let's say here you will be getting somewhat around 123 addresses we are getting. Out of this 123, no machine will get any permission rather than except RDP. Only RDP will be here, no other. Because what we are going to do is we are going to check our network ACL here, our network ACL, and we are going to associate with the subnet. We do have this sec subnet and we can easily associate. I have associated, right? Now in the same subnet, let's say this subnet, you can route it towards internet gateway to make it public subnet. You can route it, this subnet, you can route it towards internet gateway. So let's say I'll create an internet gateway here, IGW, for my VPC which I have created. So what will I do is I'll attach it to my VPC. After creating it, I'll attach it to my VPC. And now I'll provide a route also, because I have created a simple subnet. Simple subnet. Where is my subnet? This is my subnet, and I can check out the route table. So it is showing there is a problem in the route table. So what we can do is we can just find out our main routing table. So what we can do here is we can select our own routing table here as per the IP address. Sorry, I guess this is our routing table, right? How will come to know? If we click on route, we did not use this. We have used something else. Route table is showing 3 only. Our VPC is sec VPC. In this VPC, we are having one route table. Main route table did not created here, guys. It did not create main route table. It is showing some issues. So what we can do is we can create our own route table once again. We can just give let's say RT route table for my VPC, and we can just create, and we can edit the route towards internet gateway, so that it will get the internet from everywhere, and we can save it. Now our subnet is public subnet. It means that if I'll create any machine, so it should able to connect. It should able to connect with that machine. So if I'll bring you to the EC2 now, if I'll bring you to the EC2, and if I launch the instance here under the, let's say if I'll just write here Windows machine to just verify the Windows 2025 base. Let's do not use this. Why? Because it will take T3 micro. We have to use T2 micro in free. Let's say create a new key pair. If it is a key pair, I just give the name, and here in the network I'll edit this, right? This is my sec VPC. Here I'll be using my subnet. Here I'll enable the public IP. In the security group, guys, check it. In the security group, I am allowing RDP here. In security group, I am allowing the RDP. It means that if I create this machine, RDP is allowed. If I create this machine and if I'll try to connect the machine, it should able to connect. Only it can connect the machine. Rather than connecting, it cannot do anything because everything has been blocked. How it has been blocked? If you need to verify, you have to go back now. Now you have to use reverse technology. So the reverse technology is, first of all, you will check this machine belongs to which subnet. So you will just click here and you will go to the networking. In the networking, you will come to know this belongs to the subnet, this one, sec subnet 1. So you will go to this subnet. Once you will come to this subnet, you will verify whether this subnet has been associated with which network ACL. So you will go to the network ACL, and this is my network ACL. I have allowed only 3389. And if I remove from here, it won't connect. It will not connect. If I remove this from here, it will not connect. Even though you are keeping in so many thousands protocol you can keep into the network security group, it does not have any problem, because from the network only everything is blocked. See, if you are entering, if you are trying to enter into your room, and if the main house door is closed, so it is difficult to enter into the room. Like the same, if it is blocked, if we have blocked the network, if we have this traffic is telling, if this is the machine which I kept here, this is your subnet. Here you have added the ACL. Every traffic will pass through the ACL only, and this ACL will allow only RDP. So only RDP traffic will go from this ACL to this machine. Later on, this machine will check also into the security group whether RDP is there or not. So the primary is network ACL and secondary is security group. And if you need to work for protection of your network or subnet, you will be protecting it by using the network ACL, not with the security group. Security group is only for EC2 instance. And this network ACL is for subnet and network. Means VPC and their subnets. I hope you understand, guys.
Yes, sir.
So now I have created that machine, and if I'll show you, just to connect this machine, and let's check whether we are able to connect it or not. So I'll just click here, connect RDP client, and we'll just download the remote desktop file. We'll try to get the password first. This is the key pair, and we'll decrypt it. We'll copy the password, and now we'll open this file. We'll click on connect. See, guys, not connecting. Why it is not connecting, anyone?
Sir, in route table, you have not added that internet gateway, sir.
I have added now. Everything I have added. See,
Okay, it is not initialized, I think, sir.
see, I'll show you. See, this is my subnet, sec subnet, and what did I do here is I'll just go to the route table, right? Route table we did not add, right? This is what you are
Yes.
saying. Very good. So we'll just edit the route table, and our
Sir, in route table only you can edit that one, sir.
yeah. So we can check it out, our route table. This is what we have created, and we have routed it towards internet gateway, but the subnet association we did not do it.
Yeah, yes,
So
sir.
we will just add this subnet, and now we'll open the same file. Fine now, because our we have given every possible way to access this machine, from machine to, see, this is again not connecting, from machine to, let's say, we'll download the remote desktop file again, and we will try to open it again, and we'll try to connect it again. Our general setups has been given here. This machine is here. See, this machine is here, and in the machine security group, if I'll show you, this is our machine. If I'll bring the security group of the machine, it is having the port number 3389, which is allowed TCP from any source, which is allowed. In the outbound also, all the protocols are there. So this is perfectly correct. Security group is fine. Again, now we'll verify the subnet. So our subnet, if you see, Our subnet is this subnet, sec subnet 1, and this is only the sec subnet 1. If you go to the subnet 1, sec subnet 1, this is our sec subnet 1. And in the sec subnet 1, if you check the route table, it has the route to the internet, and it has this traffic also, but still it is not able to connect. The reason is so simple. The reason is so simple, guys. When this traffic, let's say this is our virtual machine EC2, which we are connecting using a RDP protocol from our local PC. This is our local PC, right? From local PC, we are connecting through the RDP. Who is coming in the middle? First, this is into a subnet, so there is a network ACL, which one is coming into the middle. After that, the security group is perfectly fine, so that is not the issue. The network ACL is the problem. Network ACL is telling, okay, whatever the RDP traffic is coming to this machine, let it go, but let's do not return that traffic back. And you know how the station will stabilize? If it is saying hello, if it will send the hello, this will take hello, and then it will say acknowledge. This will be coming back again hello with the acknowledge, and then this will say acknowledge, then this will acknowledge. Then the connection will get stabilized. So for stabilizing the connection, this both how you are going here, and this should also possible. This should also possible. So for making it possible, what we can do is we can go to our network ACL, which is this one, and in the network ACL, we can check out our outbound rules and we can edit our outbound rules. We can add a new rules. We can just give one or 1 2, and it is nothing but priority RDP protocol we are talking about. And this protocol, here we can keep our machine address, so it will be working from my machine only, or we can just add as it is. We are keeping allow only. Now let's try the same instance to connect.
Sir, if we allow all traffic, it is connecting, sir.
All traffic it should connect, or by default all traffic we will do, it should connect, but it should also connect now because we have allowed both, right?
Yes, sir.
Because in our ACL we have this we have allowed in the inbound rule, and this has allowed in the outbound rule. But let's check it out. All has been given. Edit. This is allowed. Okay. This is also allowed. Both are allowed. Then why it is not coming? Save the changes. In the security group, both are perfect. So all traffic is denied, and all traffic is denied except this traffic. Subnet association is correct only. Let's try one more time, guys. We are using only RDP. not any other protocol. So only RDP we are using here. It should I'm sorry. It is blocking itself. It is blocking, guys. It is blocking. Let's modify the inbound completely. Let's modify inbound once. Let's make it all, right? Let's try to make it all traffic once, and then let's try. Huh.
But it is coming soon.
For keeping all inbound, let's check it out. For outbound also you are keeping all, it seems, right?
In outbound, we can keep, sir, if we keep all traffic, it is coming, sir. In inbound,
Keep
we
only
if we add
one.
RDP. Yes, yes.
Correct. So let's do the same here. Edit inbound. So this we are keeping only RDP, right? This was RDP. We'll save the changes. Means in main traffic is the inbound, guys. Main traffic used to be your inbound, because that traffic only will allow who is reaching to your resource, right? And where your resource can reach, that is the secondary. That is what you will be thinking once after, accessing the resource, where we have to go, where we need not to go. That is the secondary. The most important thing is your inbound only. So let's try one more time. Let's see whether it is connecting or not now by changing this. See, this is asking now to connect, right? This is asking now to connect. It means, it means in the outbound, apart from RDP, there is one or two other protocols or ports it is asking to open. That's why it is taking. In inbound, it is fine. In inbound, it is fine. See, it is working now perfectly. But if you go back and if you just modify this rule under the inbound, edit inbound rule, and if you remove this or if you deny this, and if you save this, and now if you will be able to access, in your security group is not doing anything, it is having all the permission allowed. So it will work above your security group. It will not connect now, as it was not connecting earlier, right? So see, when I say architecture, so you need to understand the concept of architecture like this. What is the meaning of architecture here? The meaning of architecture is, let's say, if I'm telling you, where is the blank page? Yeah. So the meaning of architecture is yeah, how to design the network, how to design the network and its component, or how to design the network traffic, how it will flow. So as per our calculation, as per our uh, setup which we have done, so we have created a VPC. And in this VPC we have created one subnet only. This is subnet 1, and this subnet 1 was having one EC2 instance machine. This is our laptop. Now we are connecting this laptop using RDP protocol to this machine, right? This is our target. And this is your VPC. Now this VPC is associated with the main network ACL. Main network ACL, this is associated. And separately, this subnet we have associated with the different ACL, new ACL, or yes ACL, you can say this ACL, which is here. Now this RDP will come first. It will see this border rather than going there. First of all, you see this border. This is the ACL of VPC. So first of all, you should allow here or you can deny here. That is first thing in your architecture. Second thing, there is again one network ACL here, you can see. Rather than keeping your network ACL here, I'll just show you again. Yeah. So rather than keeping there, what we can do is we can keep one network ACL here. So if the traffic will pass from this VPC ACL, the main network ACL, then only it will enter into the subnet, and the subnet is having another ACL. And here only we are allowing the RDP. If RDP is allowed here into this ACL, it means that in the security group later on we can allow while creating, so that the RDP can easily in. Are you able to understand this architecture, guys?
Yes, sir.
So if you go back in your VPC main network ACL, VPC main network ACL, so there you will be finding out, let's say this is our VPC, and here if you go to the main network ACL, so main network ACL is not there. Main network ACL is missing out, it seems, for all the three VPCs. Is it? Sorry, we will refresh, it will come, guys. Yeah, are you able to see? This is our VPC. The main ACL is this one. If I'll open this ACL, so here if you see, all traffic is allowed, right? Here you can also keep only RDP. Save the changes. It means that now I'll bring you to the same picture again. It means that in the main network ACL, you have allowed only RDP, and in this subnet ACL, you have allowed RDP. In security group also you have allowed RDP. It means that now this traffic can easily enter into this machine to connect. If any place, either here, here or here, if any place RDP is not there, we cannot connect. So this architecture says first check with the network and then subnet and then machine, or first check with the machine and then subnet and then network, VPC. Understand? If you do have one more subnet here, so the same main network ACL will apply to this subnet also and this subnet also. Separately it can have another ACL as well. If you need to remove from this ACL, the main network ACL, you can remove this subnet also from this main network ACL, and you can associate with the different network ACL as well. Let's suppose in the same lab, if we see the network ACL, this network ACL we can associate with the our subnet here. Save the changes. Now we'll go back to subnet. And this is our subnet in network ACL. It is showing error again and again. Yeah. So this is having network ACL for this. Inbound rule is this one, outbound rule is this one. So edit network ACL association. Network association to this subnet is either this one or this one. So are you able to check, guys? Are you able to see either this this is having the default associated, right? This one is the default associated. Now we are associating it manually so that inbound is denied, outbound is only allowed. So if we save like this, it means your subnet, this subnet is having ACL which we have created, and in that ACL all the inbound is denied and outbound is allowed. So again you cannot connect the machine. Are you getting my point, guys?
Yes, sir.
If you do have any doubt, please let me know, because you know the concepts are really important to understand. This is the networking stuff, so it means we need to know how to place, where to place, right? So you came to know like basically where to place for security reason. Now, of course, one thing, if you see here, once you see this, if something is there to filter, either it can be firewall, or it can be IPS, or it can be IDS. These entire things we should use out of the network, in the middle somewhere, then only it will filter and send the traffic to our machine. Now if you will use it inside here, let's say there are two subnet. In this subnet you are using firewall, in this subnet you are not using firewall, so this can be, you know, exposed. There is a possibility to expose it. But now we came to know the, you know, architecture, basically where we can place. So from outside to inside, in between of it we have to place. That is the outcome which we came to know now. Moving further, when I say for architecture, in your network architecture protection, you can use also the network firewall. A network firewall is a protection mechanism which will filter incoming and outgoing traffic. See, now we are talking somewhat more in terms of what to filter, what to not filter, what to filter now, what to filter. So the question will be coming, can we filter only protocol, or can we filter only IP addresses, or can we filter any pages also? So everything you will try to filter now, because your firewall basically will try to send the packet, or it will try to block the packet based on source and destination IP address, based on source and destination port number, and protocol type. So three things are coming, means IP address, port number, and protocol. These three things, guys, these three things are the, these all are the three you can say identity, or you can say if you need to filter the traffic, you can filter on the basis of IP address, port number, and protocol, right? You can filter based on it. If you will be learning the network ACL, guys, or ACL, not network ACL. So ACL basically it used to be of two type. If you will be learning in future, access control list is of two type. One we used to call standard ACL, and second one is extended ACL. Extended ACL. So standard ACL will filter only, it will filter only the port in protocols. Sorry, ports in IPs. When extended will filter ports, IPs plus protocol. So when we say ACL, it means that we are talking about the extended ACL, where we can filter based on the port, based on the IP, based on the protocol. So this firewall will filter based on the IP address, port number, and protocol type. As the ACL is filtering, like the same, firewall will also filter. But firewall will do somewhat additional stuff that I'll tell you more. In the firewall can be hardware or software that you all know, and if you need, you can check it out. Palo Alto on the Palo Alto, Firepower, Checkpoint, like that. There are so many. You can check it out on the internet. For example, if I show Palo Alto here, Palo Alto Firewall appliance, so it will just give you the hardware. So this is the firewall. This is the Palo Alto firewall. This is again, so many generations are there into the firewall. Or if you can see the firepower, this is Cisco firepower, right? Cisco firepower. Cisco firepower. Next is, I said one more, guys. Palo Alto firepower, and one more I said. Can anybody tell me the name? Anyone?
Cisco, sir.
No. I have taken three names: Palo Alto, Firepower, and one more has been skipped from the mind. Okay, let's keep Juniper here. Let's see, Juniper is there. Juniper is also there, guys, security. So, see, it's all about, it's all about the product and the use case. Now, if you need to use or purchase this firewall for your local protection, local area network, for that, if you need this, you have to check which one is better and which one is not better. So again, there is a solution for checking it. Gartner is the same. Gartner is there. Gartner firewall quadratic, magic quadratic report of 2000, whatever, 2000. So here we can see which one is on top. I guess Fortinet. Fortinet is on top. Are you able to see my screen? Leader is Fortinet. Right? So Fortinet firewall is better in terms of completeness of vision and ability to execute. Means it is better. So overall, if I tell you, yeah. So these firewall will be having different features, guys. Different features. And number and placement of firewall is completely depends on the network topology in your architecture, and this is nothing but your architecture of it. So there is one example that has been given. Let's say this is your corporate network that we can call intranet, and this is your public network towards the internet. This is untrusted and this is trusted one, because this is your own. Now what we can do is, let's say if you divide as per the inside, outside and firewall. So this is how the communication happen. This is inside, this is outside, and the traffic will pass from this network firewall and it will go to the internet. or from internet, from outside it will come to the firewall, and then it will go to the inside. So in the middle of it we are using the firewall. In the middle of it we are using the firewall, right? Firewall. By the name you can also understand fire and then wall. This is fire and this is wall. So if any unauthorized traffic will come from outside, then this will bring the wall first, means you cannot go there, and after that this will give the fire. Fire means it will just drop down that packet, nothing else. Okay, moving further, in the firewall, guys, what you can do is, first of all, you will start by explicitly deny all the traffic and then permit only one you need it. First of all, you will deny all the traffic. Now you will allow what you need, as I did it, right? As I did it. So you can block traffic that is directed to the network control device unless it is originated from a trusted network. So that we can call that there is something called stateless that will come into the same. You can get the log all exceptions. If you do have some exceptions, that you should also keep into the same, keep into the rules. You should keep that exceptions into the rules also. And exceptions used to be less once you will be using the priority, right? And then supplement network firewalls with the application firewall, right? You can use network firewall with the application firewall. It's a supplement. Network firewall best practice. Now you need to understand how basically it should be designed so that we will be able to get the best practice of network architecture and network design. So it is telling use firewall to create different network zones with different level of security. So we are using firewall, guys. Here we are using firewall to create different zone. This is my private zone, or this is my inside, and this is my outside internet. Now if something is coming from internet, then I kept one firewall very close to the perimeter zone. This is partially controlled. This firewall will filter the traffic like this is not allowed, this is not allowed, this is not allowed, and this is allowed, this is allowed, this is allowed, this is allowed. So whatever things are allowed, what is not allowed, as after this firewall it will filter and it will bring into the perimeter zone. From this perimeter zone, once the same traffic is trying to enter into the inside, that time one more firewall is there. Now you need to go through this firewall. So it is telling us you are going to protect your, if you will protect your perimeter zone, it means that you are able to protect your internal zone also. And this is what this is how it will look like. This is a firewall. This is your inside. And this is your separate zone. This is outside. Traffic will go from here to this firewall, and then it will go to the inside, from inside go to the firewall, from outside. This is how the communication will happen. Now then, what is the use of, what is the use of this zone basically? So let's say if we are sending the traffic from inside, let's bring into the different color. Let's say from inside traffic is going to the firewall, from firewall it is going to the internet, and from internet again it is returning back to the firewall. From here it is going to the inside. This one communication is clear. Now this zone, from this zone some traffic will come to this firewall. From this firewall, this traffic will go to outside, and then the same traffic are different, generally not the same. If anybody will from outside will come to this firewall and they will try to reach to this inside, they will be able to see only this one, this zone only, or it's up to them which they want to show. If you want to show this zone, you don't want to show this zone. Zone means you can divide this in inside part in two part, and you can use this zone and this zone, two different zone. So if from outside to firewall, from firewall, if we are not reaching to the actual zone or private zone, it means that we are going into a zone called demilitarized zone. Demilitarized zone means for showing there will be one, for showing purpose there will be only one network. People will come and see this is the network, but that will not be the actual network. Behind that there will be an actual network. In the zone where we are seeing like the false info about the network is demilitarized zone. So this is how the people used to protect their network, guys. There are so many things. And the next one is AWS security group. Security group, you all know. A group is implemented as a firewall to protect your EC2 instance, and it will act as a built-in firewall for your instance. You can associate with the network interface of your instance. You can define only allow rules, inbound and outbound both, and it is stateful. It is stateful means, again I'll tell you, if it is your machine EC2, here we do have security group. So whatever inbound means if it is RDP is inbound, so RDP should be there in outbound also. RDP should be there in the outbound also. If RDP is into inbound and in outbound, it means that this state is getting maintained here again. It is stateful. Whereas in your ACL, means network ACL, you can modify this RDP is allowed. This is RDP which can be blocked. This you can do there. It does not maintain the state. Here inbound, if it is there, then outbound should be also there. Here it is not necessary to maintain the state. That's why security group is stateful and ACL, network ACL is stateless. What it can filter? It can filter protocol, port number and IP addresses. Protocol, port number and IP addresses, source destination IP addresses, it can filter. There is one example. Let's say this is internet client. And now from this internet, this particular client is trying to reach to this web server instance. So the source is 0.0.0, the port number 80, it should allowed intranet IP address, port 22 also it has been allowed. So basically what exactly we are doing? Sorry, this is our internet, this is our intranet, right? This is our intranet. So from here, if somebody is trying to access from intranet or from internet, so here it is HTTP, simple. Nobody can connect with the RDP or SSH. Is it clear, guys? This part is clear. HTTP and internet client. I hope it is clear to everybody, this part.
Yes, sir.
Because it is HTTP. HTTP cannot allow the remote desktop, right? Either to any security group, it won't allow. Who will allow? Let's say there are some people, there are somebody who is into the intranet. Intranet means within the same network, you can say they are in the same network. Now this security group has allowed port number 80 for this HTTP fine. This one is also allowed. This is also allowed for application tier rule number 1 443. This goes to 443 goes to HTTP. Yes, HTTP S and RDP 3389 and SSH 22. So That's so simple. If I'll write the rule based on the 3 security group, so it will look like this. See, for the first security group, let me delete everything first of all, so that we can write it proper. And they have also written, but it is not so clear. They did not add, the inbound and outbound. That's why this is showing some doubt. All right. So the rule number 1 for this security group is, this should have the inbound. This is from internet, the traffic is coming to this. It means that HTTP port number 443 should allow an HTTPS, it is an HTTP port number 80. This should be into the inbound, and it is a security group, so it should be in both inbound and outbound. This is the for first security group, this one. Is it clear, guys? Is it clear to everybody?
Yes, sir.
Now the outbound, the first one outbound, for the same, for this one only, what will be the outbound? Now this machine wants to access this machine. This machine wants to access this machine. See the arrow only. This machine wants to access this machine. The arrow is going through this. So what we can do is, in the outbound also we can allow SSH, because this wants to connect by the remote to this machine. So we can give SSH port number 22 will be into the outbound. It means that in inbound this and these two both will be also in the outbound along with this also, because it's a security group. I hope it is clear for the first this one. Okay.
Yes, sir.
Let's talk about the second one. So for the second one, if you see the arrow, you will be having much more clarity. Now there is, how many inbound and how many outbound we do have here? In the second one, guys, how many inbound, how many outbound we do have? Guys, in the second security group, how many inbound and outbound we do have?
We are having one inbound and two outbound, sir. One rule is
2 inbound, right? This is one, yes, and this is one, and one only outbound. So your inbound is SSH. Inbound is SSH here, and this is also saying the same SSH should be there into the inbound of this machine. So SSH should be this, SSH should be this. It means that here you should write SSH for both this source and this source. It means you will be writing SSH for source number 1 and again SSH for source number 2. Clear? Clear, guys? And this is into inbound. Now if you write the outbound now, so for outbound you do have only one, which is database tier. So if the database tier we are using, let's say for database, if we are using some port for database MySQL, so this should be into the outbound here, outbound, right? Here it is outbound of this one, and the same will be into the inbound of this one. Are you getting my point, guys?
Yes, sir.
So the last one, this security group is not having any outbound, but it is having 2 inbound. Okay. So this is how you will be designing your traffic basically. Then we do have IPS. IPS stands for Intrusion Prevention System. It will actively protect your network against threat. It will monitor network traffic, detects threats, and automatically defend them. So they do have, different types of threat detection mechanism strategy, or you can say different types of threat detection mechanism they are using to detect the threat. And the first one is anomaly based detection, and second one is signature based detection. and this also can be a hardware or software solution, and it is usually placed behind a network firewall. So if it is your internal server, there is a firewall, so just behind the firewall you will be keeping IPS, and this is the attacker and hacker. So they will try to hack the server 1 or server 2. First of all, they have to come to the firewall, and after the firewall they need to go to the IPS, and then they can go into the server. First firewall will block or check, and then this IPS will. So IPS will do on the basis of two: anomaly based detection and signature based detection. When we say anomaly based detection, guys, see, the detection technique is so easy to understand here. When I say anomaly based detection, so what it will do, let's say initially the normal day traffic, it will try to compare the normal traffic daily basis, what all are the traffic, what type of traffic it should come, what type of traffic it should it is made for. If somebody will try with the anomaly, means different means deviation. So the IPS compare the current traffic pattern against the stabilized baseline for any deviation. If deviation will come, immediately it will detect. And then we do have IPS monitor also. It will analyze the traffic for known patterns of attack. Basically, this signature based detection, we will be having some of idea about the threats. Some idea this will have, signature based detection will have somewhat idea about the threat, how the threat look like, and how the threat basically will be. It is virus, it is Trojan horse, it is malware, what exactly it is coming through the network, and if it is a malware, what type of malware it is. So generally it used to have the signature means definitions. It used to carry the definitions of pattern of attack. It knows how many number of ways are there to attack, so it knows. Once it will come to know about the pattern, it will easily identify this is someone, or this is how someone is trying to enter into the network. So here IPS example, we will be using AWS network firewall, and here in the AWS network firewall, we can also inspect the traffic flow to protect the network from vulnerability exploit. So here you can see, you will create a VPC, you will be inspecting your traffic rules and everything, and at the end you will be using a signature based detection engine. So you will be able to check which can be dropped, which can be separated. And later on, the last we can see, we do the segment of a network also to protect it, which we used to call subnetting. So you can do the network segmentation to apply different security controls to different part of your network, right? It will create a smaller logical network from a larger network. So each logical network is called subnet, and each subnet is assigned a continuous subnet of IP address of the large network. And then the CIDR part that we all know, so no need to go with that much deeper. Here we can see the example. This is your internet. From internet, the traffic can go to your firewall. From your firewall, this is your perimeter zone, means again firewall will come. And here the router is there. From router, the traffic will go inside. Here is network ACL. Here is the network ACL. This is one subnet. This is another subnet. And these all are your servers. So multiple places are there which you can use in your architecture to protect it, right? In the network ACL also we have seen, ACL also work as a firewall in the cloud to protect your subnet. An ACL filter inbound outbound traffic, and it is typically implemented in a switch or router. It is stateless, and it is typically implemented in switch or router. I think we are using switches or router to implement, but this is again wrong. We are using switches and router to implement, but we used to implement the ACL on the port of your switches and router. Let's say this is the router. It is not wrong, it is correct. Means when I say port of router or switch, it means that router or switch only. It can be more clear if it can be the port of switches and router. So this port, it will apply the security to this. Now we do have it is telling stateless, so incoming, outgoing, or inbound, outbound, both we can filter and we can check it out. And it is associated with a subnet in a VPC. So one ACL can attach to multiple subnet, but one subnet can have only one ACL. Okay, a layered security model for VPC on AWS, network ACL protect at subnet level, security group protected as a instance level. This is the outcome we got. All right guys, we are done for the day, and this is what we are having into the network hardening.